Yeah. But you're muted.
Okay, here we have our second webinar section. And hello, friends and dear space enthusiasts. I heartily welcome to today's webinar section conducted by UL Space Club. UL Space Club is formed by under the leadership of former ISRO Director E.K. Kuttisar in 2016 in the umbrella of Uralangal Labor Contractive and Cooperative Society, and successfully connected hundreds of students across Kerala to globally renowned professional and provide hands-on experience to youngsters under the mentorship of Kuttisar, Jairam sir, Shazil sir, Damodaran sir, Shahin sir, Surendran sir, Ajin sir, and on. We chase our dreams and nurturing ourselves. Real Space is conducting space camps, Monday Space Week programs, quizzes, and webinars. Now we have our 70-second webinar section on the topic Touching Lives While Touching the Moon, Indian Space Odyssey by former Director of ISRO, Dr. S. Rangarajan sir. It takes us on a journey through India's incredible space missions, and you will discover how India's space program has not only reached the moon, but also transformed lives here on Earth. I wholeheartedly welcome you, sir. Next, I welcome the eminent personalities who are present here to encourage and motivate us. I welcome you all, and also the future enthusiastic ones, my loved ones. I welcome you wholeheartedly. I hope you all have a great day with this webinar class. I welcome you. Thank you.
Thank you, Anju. And Anju is our Space Club member who is studying for his integrated MSc at University of Calicut. And a very good afternoon to all. We are here with the 72nd webinar session of UL Space Club in this occasion. And we are proud to say that we are sitting continuously. This is happening for our students and our teachers and science enthusiasts all over the country. For the past 72 months, we could see that. And with the support of most veterans from ISRO and under the guidance of our former director, E.K. Kuttisar. And today, we are discussing on the touching lives with the touching the moon, the Indian Space Odyssey. And we are hearing it from an elegant personality and eminent scientist of ISRO who pioneered several missions and designed several prestigious ISRO missions for us. And Dr. S. Rangarajan is continuously supporting UL Space Club for the past few years. And he come to Calicut and spoke to our students and supported us with some former webinars also. And he wholeheartedly accepted invitation in this session to speak with our students on the near day of our National Space Day that will happen on 23rd of this month. And we are also celebrating that occasion, the proud moments of ISRO and touching on by soft landing on the moon. And let me formally introduce today's guest, Dr. S. Rangarajan for you. Dr. S. Rangarajan is a satellite industry veteran with about 50 years of experience in successive leadership roles in public and private sectors. He has been holding an interest in the development of innovation that seek to prove better quality and affordable solutions for rural and remote regions of the world. Dr. Rangarajan has held several executive positions in ISRO, including Director, MCF, Director, ISTRAC, and Director, SATCOM, Program Director, INSAT. Throughout his career, he has pioneered various satellite applications, including first satellite-based telemedicine project in India. When Dr. Rangarajan was a chief technologist in MNC, he successfully adapted the satellite radio infrastructure to design diverse solutions for data multicasting, distance education, and early warning delivery in the developing world. He was responsible for the design of world's first satellite integrated tablet for the direct delivery of education to teachers and students. In the last 7 years, Dr. Rangarajan has been supporting a number of academic institutions for space studies and development. Besides, he has devised field-proven measures in rural schools which will not only improve the average learning level of the students, but would bring in more uniform quality education. He is an advisor to Prayoga, conducting studies on education research. He derives immense pleasure when his experience and expertise directly benefit the teachers and students that we are getting for the past few years for the UL Space Club and the student community connected with this occasion. And is an eminent personality connected with the design of moon mission of India. Principal objectives were designed under his leadership. It happened here. And we are so proud to have our Dr. S. Rangarajan here again with us as a speaker. And warm welcome, sir, to this forum. And I invite all the veteran scientists, our founder E.K. Kutty sir, K. Jairam sir, P.J. Bhatt sir, lot of veteran scientists are there, and we'll get reflections of these scientists after this talk. And without taking much more time, I invite the veteran scientists of India, Dr. S. Rangarajan, to this forum. Welcome, sir.
Good afternoon, Shajal. Thank you for a good introduction, and to Anju also. It's of course always a great pleasure. It's like a homecoming when you want to give a talk with the UL Club, because I really enjoyed my visit there. I know several of you personally, and it's so great that over such an extended period, you are able to sustain the interest, grow the interest, connect with more and more people. So it's always a pleasure to be talking in this particular forum. Of course, we chose this tagline, which is being talked about in this month very much, the touching lives while touching the moon. And as far as the Indian program is concerned, touching lives is much, much more important and significant compared to the touching of the moon. Of course, we can do that, but we have done much more. In fact, there is a very, very large number of people, maybe almost everybody, who has directly or indirectly benefited from the Indian space program. I thought I will divide this into 4 parts. The first one, setting the stage, where the perspectives will be explained as to how we began. And that, of course, led to a great success. So we have to understand that any number of times might have been told, but we have to go over that. Then pick up in what ways we have done the touching of lives, the applications, a variety of applications which have again been very systematically approached and achieved. Then touch upon the all-important Chandrayaan 3, because as we get at my calendar and every day when I take the one day I remove, I will immediately remember, August 5th, this is what happened. So to that extent, it has got into our thing, and waiting for the August 23rd is something which happened last year, it will happen this year, and in every year. And finally, I also want to present in the 4th part, the outlook. Well, what are we going from here? It's not the end by any means. It is just showing that it's a journey in which one of those wayside stations we have crossed is going faster, better to its destination. It keeps going and going generations after generations. So that is what we would be touching upon. And again, this being a small and very friendly audience to which I am talking, you are most welcome to stop me and ask me to explain something if something I have missed it. But I would want to begin with the initial stages. One slide like this. In fact, a lot of people helped me. In fact, the slide which I am putting up here is Dr. Hegde was presenting it in one of the classrooms. I said that, this looks so good. In what I would have taken 3 slides, you have made it so beautifully. So he gave me this. And it summarizes how we began. It's called humble beginning to commendable achievements. And we began at a time when the country was in the very nascent stages after the independence, and there are hardly any other countries besides USSR, US. There was not much of space activities. It's just 7-8 years after the first Sputnik. But then we already thought India must have the in-course power, and then you start for whole activities like that. And once that came up there, it had number of very important things. You read outcome of conviction, commitment, cooperation, and political will. See, right from the beginning, our program was bottoms up. In the sense, we started from the applications and we built up what is required as a payload, how's the payload, what kind of satellite is required. If that satellite is to be launched, what kind of launch vehicle is required, and what kind of supports infrastructure is required if the data is to be received and distributed back to the end users. This cycle was foreseen, and if some elements were not available in the country, we didn't feel bad. We just went ahead and had the cooperation with Europe or maybe with US or Russia, USSR, and we were able to get our program moving, and that was happening all the time. So it had the Space Department, which is a government entity, and then the academia, of course, supported it very well. That had also started at that time. And very many of them didn't have a lot of formal degrees, but they were able to come back, learn on the job, and contribute as a team. And the industry also gave us very, very good support, both the public sector, private sector, etc. And then how to use the space for national development was the mantra, which we got from none other than Dr. Vikram Sarabhai. And that is also quoted very many times. Whenever somebody was questioning why at all you have taken this as a priority, when half the people are below the poverty line, somebody is not even getting a road there, and the villages don't have a proper water supply and all that, why are you taking something which is very high profile, space activities and all that? But he had no ambiguity of purpose, and none of us who come and followed these footsteps have any going back and saying that we did the wrong thing. No, never. So we are convinced that if we want to do something very meaningful nationally and also build up our international stage, we have to attack the advanced technologies to solve the real problems of the society. So that kind of an approach was extremely good. In fact, I would always want to say, this is usually referred to as the golden circle. In fact, they attribute it to, let's say, Steve Jobs, the Apple founder, because he used to make very good this thing, saying that when all the other companies are going from outside to inside like that, we were the only companies who were going radially outward, and that led to our success. But we did it even 2 decades earlier to that. We always started with, why do you want to do it? Today we give nice nomenclature like demand-driven. But it was always demand-driven. When we were all from Bangalore, we used to go to Ahmedabad. One of the things all of us used to enjoy, Vijay is here, for example, PJ is here. So we all used to sit in the Vikram Hall with a lot of people from different ministries and people who do not belong to ISRO, but they will come back and say that we want this kind of solution. You listen to all that and then decide, oh, this is what is doable, and let us do it. That kind of a crystallization was happening. After you get what is to be done, then doing it and how to do it and all that is very straightforward. But why you do it is the one which was driving the whole thing. That is what I will call the bottoms-up approach. But we got the top-down support all the time from day one. The Prime Minister had this department under him, and the support from Prime Minister was always there, and we knew that this can be brought in like that. So this built the so-called ISRO culture, if you want. It has got several important points there. That is what has touched our lives, the ISRO people's lives also, the passion. Why 2 days back only, Sri K. Kutty told me that there was a little bit difficulty of that speaker who was supposed to speak today. She could not make it, and then he said, well, can you talk? Why not? We'll talk. So that kind of this thing was possible. Okay? Everything's okay? You're listening?
Yes, sir. It's okay. It's
okay, because there was some change. All right. And another interesting thing, which at least I always mention, is there is absolutely no bossism. There is nothing like an hierarchy, and then you salute only your boss. And if there is a lift which comes up, you first give way to your boss, and all that is never there in ISRO. We always used to be friends. We always used to move with each and everyone. That helped the review mechanisms, for example. When Professor Rao used to conduct those review mechanisms, I have noticed several times when somebody who has probably seen something very unusual and yet not, suddenly that comes to his mind, you'll ask him to come to the stage and explain. And that kind of an approach is what led to how from failures you learn and how do you progress. That was another very important element. And especially at MCF's track and all that, I've also known that despite all the best of our efforts in product assurance, quality assurance, there will be some unexpected glitch. In fact, the newspapers will say, INSAT, there's a jinx. I heard such words then. But then we didn't allow the jinx to get jinxed out. Other companies abroad used to go and make an insurance claim and be very happy that, we have not lost any money. But ours says money is not at all, there is insignificant here compared to the benefits for which we have built the system. So the never give up approach, and those are all things which has touched our lives. Now, how it touches the common man, I'm going to explain more and more. And until recently, 100% of the funding for all these efforts came from the government, taxpayers' money. So it has to be accountable there. But it was funding for societal goods. And we reached, right from the experimental stage to operational stage to commercial stage, everything when we went in there, we reached a particular point of time, maybe a couple of years ago, 3-4 years ago, when we realized that the infrastructure that we have built is so fantastic that the return on investment for a private investor will be very good. We have built the roads and all that. So he has to only now drive the car. So that kind of a thing, when we brought in there, the space assets that we have created will be able to be used by the private sector. So that way we don't have to worry about public funding, and because that creation part is over the first 5-6 decades. So that kind of an approach is what was taken. Of course, this again has a lot of these pictures worth seeing, because when you get depressed, you go back and see, what is this? The greatest of the great people. Look at Aravind and Kalam. One of them not even wearing the shirt. Today, I thought for this particular thing, I must wear one shirt and came here, because those days, they didn't bother about any of those. Are very, very minor compared to the work that they were doing. This whole thing started in a church, which is shown there. That was chosen because the magnetic equator was passing through that Tumba region, and that was very good for sounding rockets to be sent from there. Nowhere else it was available, and therefore it was the house there, some of the activities, and the people managed whatever was available there. The fishermen there were sort of very cooperative in saying that, look, we don't mind if we lose our catch today, but you'll see a little later in my slides, they are going to get back. Their lives are going to improve for the little sacrifice that they did then. Going to the most important from the communication point of view, because the societal needs, when you are looking at it, one of the needs which certainly came out very, very strongly is the fact that we have literacy issues, health-related education. All these things are things for which we needed a satellite to help. Because terrestrial infrastructures go incrementally, it takes time. So we want to do such a big country like India, want to do things quicker. Satellites were providing an opportunity. So for that only, we brought this ATS-6, one of the American satellite, because we didn't have our own satellite. In fact, we didn't have a TV sets even at that time. We didn't have these antennas. All these things have become very much commonplace. But in mid-70s, that was not there. Despite that, as many as 2,400 villages, we were able to reach out in 6 different states and different languages, different culture, and all the software for that in terms of producing the programs and conducting those instructional experiment. And then all the local things like the receivers, everything was all created in the country. It was only the satellite, the space segment, which was borrowed. And we didn't feel shy of doing that, because that was an agreement reached out with them. It was moved over our region and we used it. It's one of the phenomenal sociological experiments to this date, and which paved the way for doing it right in terms of when we build our own system. The INSAT, for example, going to come back. So we would design the payloads for that, write out the RFP, go and get international bidders and be able to get the satellite and do all the coordination that is required to get them in orbit and then be able to start new programs. So that is the kind of thing which was happening. But then when you are in this particular year, we cannot afford to miss out on Aryabhatta, because just like Sait was talking about how we experimented to create the right configurations for utilizing it for television, telecommunication and all that. But we needed to have satellites. The satellites of that nature are so big and we cannot go with that. So something which can hold some payloads, and scientific interest was there in the country. TIFR was there to give the payloads. So why not try to build a satellite? Because it is like building a house. You need to have the flooring, you need to have the electricity, you need to have water, everything. So like that, even a satellite is supposed to be built. ISSP was how it was called, and it was supposed to be done. Trivandrum didn't have enough space. The Tumba church could not have had facilities for a clean room and other facilities. It's the beach. So therefore it was decided, let's move to Bangalore. But Bangalore, at the time, even now you know Bangalore is terrible, but even at that time to get some part of land or facilities, you had to go all the way to outskirts in Pina. So it's an industrial area. So it is right close to the highway with all the noise and all the mud roads and all. That's where we were working on those. But despite that, we were able to create the extremely right way of doing a satellite. And in the middle picture on the top, whomsoever is there, each one of them is a Padma Shri, and we're all very, very eminent, but at that time, see how they are all working together. And that is again very, very typical of how things are happening. In a couple of months, it will be completing 50 years from the launch of Aryabhatta. Well, of course, just this communication as one side and remote sensing on the other side, these two arms created a lot of applications. So therefore, since we are going to talk about touching lives, I have to give you an overview that there are two important things. Following Aryabhatta, we decided to have our own right type of satellites, which will do applications which we need and build our own satellites. For that, one of them was in terms of remote sensing. TV cameras were used, 1 kilometer resolution. That means only a 1 kilometer kind of an object can be seen and spotted from this satellite. So that kind of a thing was supposed to be started, Bhaskara 1, Bhaskara 2. And at the same time, communication requires a transponder, and to launch a satellite like that, building is very, very difficult and launching is very expensive. And therefore, we found an opportunity which one of the launch vehicle agencies gave it to us, saying that they were testing the launch vehicle. Said, why don't you build a satellite? We'll fly it for you. And we went in there as a middle passenger. It is called Apple, Ariane Passenger Payload Experiment. Each of these missions, whether it's Bhaskara, Apple and all that, gave us so many lessons. We have some small WhatsApp groups, and every other day somebody will mention, oh, this is what happened when this particular printout was taken for the Apple control, and this was giving an error. And that kind of memories that we have keeps us very young. Many people ask, how is it that you are now 76 and you still want to be talking and all that? That is because of the energy which we got during those days. Because going to Sriharikota in that very, very hot climate, and that's where the control centers were there, we used to sort of spend time together and learn. So that was one of the aspects. Going further on that is then I'm going to stop the perspective part of it with two more slides. The perspective is all summarized here. The Indian space program, if you look at it, on one hand, it was trying to go into building rockets, from sounding rockets to small launch vehicles, to bigger and bigger launch vehicles, SLV-3, all the way to the GSLV Mark 3 kind of thing. LV Mark 3 is something remarkable and gone very steadily, how systematically we've done it. See, because we sometimes, it's not very correct, but so we always compare it with what is happening. For example, take the Europeans. We have got so many countries. We always believe Europe is very much more advanced than us. But when it comes to building these, with so many of those countries contributing, to go from Ariane 5 to 6 and all that, they took much longer time. And it's not so easy. But in our case, we have all got that committed teams who worked on that. When it comes to space infrastructure, we, right from the Aryabhatta, Bhaskara, etc., we went into the INSAT 1 and the INSAT 2. Then in terms of the remote sensing also, more and more powerful things were brought in there, but all the time focusing on the applications. Because ISRO is the only center in the world where there's a full-fledged center called Space Application Center. The entire Ahmedabad unit, we employing 1,500 people, is only interfacing with the people who want to use the satellites. So the application is very important. Even here you see 1970, before any of these things, they were trying to find out how remotely sensed data would be usable for some actual applications like that. And site, of course, we already discussed in the previous slide. So essentially, these numbers could keep on changing. That's why I've just put 100 years of Vikram Sarabhai there to show that while this launch vehicle is one thing, but when it comes to satellites, we have any number of satellites, remote sensing, communication, navigation, interplanetary, all of them, and launch vehicles of variety of improved versions and so on. And even things like the crew module, re-entry, all those kinds of things are leading to the next milestones in ISRO, like Gaganyaan when you want to go into, etc. So when you go in this thing, I think we should move to the second aspect, where how it touches our lives, how it touches the lives of the common man, in what all ways our activities have helped those people. Of course, right from those days, there are spin-offs, when launch vehicle, they were doing some material thing like that. From there, somebody will find a way by which for a person who has had a problem of orthopedics, and you will get some artificial limb made because that material will be used here. These kinds of things are additionally there, spin-offs. But primarily, if you look at satellites go around in orbit. And so those kinds of things automatically go around. So, but once you have a station like that in which we have those payloads, those things have been created by us and kept there. So it will do what we intend to do. So we can make it do things like a communication. It can receive a signal, retransmit. So long distances you get depending on the height, because if a tower might reach out to you 100 meters or 200 meters, but here this tower is kilometers long. From there, when you relay, you get even across oceans and all that. That is one thing, the relay. And another more important aspect of satellites is the one uplink and infinitely many downlink. See, the wired communications and all is one-to-one. Whereas when it goes to nowadays, of course, people have seen a lot of Wi-Fi and all that, so you know what is wireless. But here in the satellite case, the signal which is transmitted from the satellite can be received by your neighbor as well as by you without any loss of sharing of the signal. That's very important. And the next one is if you have a vantage point in space and you can keep looking at the Earth, you can look at it with different frequency bands. You look at it with a red spectacles or green spectacles, you'll see different features and you can make out all that list and try to analyze what's happening on the Earth. It's like a selfie. That kind of an approach is there, systematic imaging, and the image products are available and they are stored and they are available to any number of agencies, government and private agencies. Navigation. See, this is one area where, again, we always anticipate well in advance. That's what is very, very important, that our think tank, you see, you saw in Ukraine war, for example, how there was some disruption of the GPS, because we take things for granted. GPS is always there. No, we won't even know many of the users. GPS is used by all of us, but we will not even know that it is done by one system, which is controlled by one outside country, and they can do some fiddling with that, and then the whole thing may be erroneous. Instead of you going to the temple, you may end up going to the sea. So all these possibilities are there. No, therefore you should have your own system was being talked about, and we are one of those very few, an operational system which is available there. Astronomy, where astronomy directly may or may not be a use, but indirectly it could. We don't know, space mining and tourism and so on. And for that, the observations are far better when you do it from a satellite, like Hubble Space Telescope or John Webb Telescope and so on. And another thing is the terrestrial connectivity and all. would require a satellite as a backhaul and all. That kind of a thing is already coming in things like the 4G, 5G, and so on. So when you look at the spectrum of benefits and the categories, one with satellite gives you the continuity. Okay, whatever you have got in one place, it is over geographically also continuous. Ubiquity, everywhere it will be available, and it can be scaled up. Because terrestrial things will be, suppose you want to do it for one village, it costs you, let's say, X rupees. For 10 villages, it will be 10X. For satellite, it's not the case because the uplink and the satellite part is something which is shared by everybody else. So therefore, therefore it becomes more equitable. Otherwise, what will happen is healthcare. If you want to provide it through these kinds of some of the space-based systems, they will provide it in every village as much as in a town. In town, it may be more difficult because some connectivity may not be easily available. There will be blockages by those high-rise concrete buildings and so on. So the benefits of space do not exclusively impact operating in the space sector, but it goes outside. The other people, without their knowledge, are benefiting from that. And that is very important. And one of the concepts which we had been talking about was the Village Resource Center, where multiple space-based services could all be co-located. In a village, they required some healthcare, all in small scale. They don't have commercial things, or big companies won't go and work there. But they have their need, they have their people. So they would want to contribute to that, making sure that the patients there are attended to, or even better, curative, preventive, is to say that, okay, better health practices and all that. Or education, for all because now I'm living absolute in a village. I know very well, there are 4 or 5 villages, I keep going to these schools. Their problems are very different from what you get in the top-notch schools. Top-notch schools always would want, and they will keep on saying, we got the 1st rank, 5th rank, and 8th rank. Another school next to that says, we got the 1st rank, 3rd rank. I don't know how the 1st rank is in both the places, but probably shared, we don't know. But in these schools, they don't care for 1st or 4th or 10th rank. They have the people who are, let's say, only 20% of them pass, 80% are failing. If that 80% could be made as 5% and 95% pass, it's a great achievement for those village houses, because they have been very much depending on this one person to be educated, so their style of living will change. And that kind of thing can be very much done. And it is not, and as we talk to people, there are so many new things come up. And they want to add on at that particular place, agricultural monitoring and all that. Now that we have Internet of Things and then collecting the data. Inside days, we used to do what's called data collection platform for collecting weather data. But now we can get local data, centralized, analyzed. One milk distribution company in Gujarat is doing it for all the data collection of milk and putting it on a computer. Everything is done on a satellite-based system. Of course, you may think, oh, these are all looking very high-funded, may not really benefit the end user. The best of the best examples is happened very, very beginning, because Vikram Sarabhai was very clear that when the fishermen have helped us, we should help the fishermen. So one of the first things which happened when they looked at the remote sensing data, right, from IRS-1A time and all, is to look at some components like the chlorophyll content, sea surface temperature and all, make models. And then it will tell you where are the schools of fish. And now what you do, you give this as an advisory to the fishermen. So with much less effort, a much bigger catch. See how much beneficial it becomes. 1.27 to 2.12 is the cost effectiveness. And that is very much possible. And this is typical of so many other examples. So in terms of the space program and its applications, how it is affecting or touching our lives, it touches because of the space infrastructure, which we have built, Earth observations, communication, etc. Space applications we have developed, because if you create the infrastructure, but do not follow it up with the applications, then what will happen is you'll have a white elephant, but then it will be not used very much. But in India, we always started with applications, like we started NNRMS, National Natural Remote Sensing Management System, RRSSCs, and so that will percolate down to the state level and villages and so on. And the capacity building, human resources, everything, the technical infrastructure, technology transfer, and things like that, and the space transportation. And all these things are put together into a simple, nice program, which is handled by the SAT. So look at the range of altitudes. When you look at satellites, I said it's going around the Earth. It can be going around in low Earth, maybe 500, 600 kilometers orbit, or it may be geostationary at 36,000 kilometers. It may be going even to the moon, 385,000 and beyond. See, all those things we were covering, but those orbits are classified. Usually you talk about whether they are on the equator, it's going down, or whether it's polar, whether it is inclined, and whether it is circular or very elliptical. Depending on different countries, they have different. Molniya has got very highly eccentric orbit, so that most of the time it is over the Russian region and so on. So all these are different characteristics of nowadays, of course, what's called constellation of satellites. Now, a large number of satellites belonging to the same company, working in conjunction, trying to address your issues. So that the low Earth orbit, otherwise, there will be gaps in your visibility, so services may be discontinuous. So those are all avoided when you use a constellation. So that kind of a thing. In fact, I was we always talk about the geostationary orbit is one in which, with respect to Earth, the satellite looks as though it's not moving at all. See, even objects like moon and all seems to move because of the Earth's rotation a lot. So Earth's rotation and the satellite movements are matched in the geostationary orbit, which was written out in one of the very popular science articles by Sir Arthur Clarke. And I had the privilege of meeting him when I was designing a disaster information warning system, and after the tsunami. So that particular first of the receivers, I went and presented it to him, and he was very, very thrilled, saying that we want finally applications should come out of such possibilities. So these are all things which can be done. And one other thing which always comes to my mind when the first time satellites came in, because we all come from a region when we didn't have proper television programs even. When in Bangalore even, we didn't have the TV station, all came in later. And program used to be relayed from maybe Mumbai or Chennai and all. But then there was a time when you have now directly, you can deliver the television programs to households. We call it DTH, direct to home. Now you have all those different companies for which ISRO has made satellites. For suppose you take Tata Sky, they have a satellite built for them, and then they are using those and then delivering this. The advantage of this is, look at this. This was taken about 50 years ago in Dharavi in Mumbai, and they may not have roof there, but they have a rooftop antenna. Because antenna is very important, because if Olympics, if they are getting to see the hockey match live, your neighbor, how can you not do that? So you should have the television. And the television may be black and white those days, but then still had these antennas sitting there. So to that extent, whatever you get in the poshest 5-star hotel in a big metro, you get it in the slums also. So that uniformity the satellite brings in, and DTH is a very good example. Of course, SATCOM has a number of applications. I'm not going to go into the very many details, because when you say affecting lives, it affects because of education it does. Health, I already mentioned. Entertainment also I mentioned. Disaster warning, I had mentioned. Disaster prediction, it's very important. In fact, we are now sitting right here, in fact, have some meetings with the state government agencies in terms of what happened in Uttar Karnataka, in that Khandra district, where Shikur, that place where there was a landslide, and what kind of data is available, and what caused it, how do you prevent it? Next time, how do you create a warning system for landslide? All those things are being discussed like that. Navigation I mentioned, and predicting for the fishermen also as explaining. There are some other things like the security strategic users. I'm going to just mention it a little later. But then remember that every ATM here, for example, is all connected by a satellite. Satellite links are universal everywhere. That's why you're able to get ATMs in those places and so on. So if you even look at this from just the very beginning of some borrowed satellite brought over India, and then you leased, and then trying to develop some applications, to now having, here 18 satellites, 300 transponders in 8 different locations and all that. That's the way things have grown. And we systematically built all that. It's not just building the satellite. You have to design what should be going into the satellite, where it should go. You have to coordinate and get it from international bodies. All those things are done and slowly moving over to higher and higher throughput satellites. Navigation, I also mentioned, it is something which is the Indian navigation system, and this is something used for aviation and for specific applications. It's not yet come down to using in your phones and all that. For that, the chips have to be made, and at some point of time, that may also happen. But presently, this is the standalone system that we have. Not to leave out space science, because I told that we started with Aryabhatta payloads, which are all basically scientific. So when you have a thing like that, you just wanted to build it more and more. From Aryabhatta, you moved on to ISRO's kind of satellites, X-ray astronomy satellite. AstroSat is something remarkable. Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, I'm going to touch upon in the next set of slides. So Mars mission, all of these are all part of our scientific observation. This is a very quick slide. I don't want you to read it fully, except to just say that the strategic users have a very big requirement of space-based systems. So they use it for monitoring, they use it for their communications, intelligence gathering, because you want to locate enemy emitter. That can be done using satellites. All these technologies are something which space can provide. So to that extent, it touches the lives of not only us, but the people who protect us. The strategic users also come into the picture. So if you want to just summarize it in one slide before we go to the touching the moon, space applications from resource mapping, land or water, environment, everything can be sort of studied very systematically. Ocean, disaster management support after the tsunami, we've also built it up in a much bigger way. And all the SATCOM applications are already touched upon. But what is most important also, that in the ISRO context, we are trying to make it available to a common user, web-enabled services, like you have heard of Bhuvan and all that. These are ways by which very easily you create an account, you access the data, you start using it. And this is something that's very, very important. And that is where it touches the lives of all, including the students. Very many of the students these days are interested in participating in all this. In fact, one of our close friends, Guru Prasad, when he's in planetarium as a director, I talked to him. He said that the kind of questions they ask are all very, very interesting, and we should now develop more and more of such things, and we'll do it. And it's very, very interesting. So now we move on to how is that 1 year ago we went about touching the moon. Okay, so when we say that moon is basically is something which all of us see, because we use it for a variety of our, at least when we come to this particular month, Shravana and all that, we start getting lots of festivals, and all of them are related to, okay, now we want to get this, for example, Vinayak Chaturthi or Ganesh Chaturthi, then Navaratri, Deepavali, all of them are all sort of linked to the lunar calendar. But now the point is, the moon goes around the earth, and earth is itself going around the sun. So the geometry is very complicated. Though I have drawn it like this, like a plane, it is not. Their planes are different. So it becomes very difficult to visualize, because three-dimensional geometry is difficult for even people who have been working in mathematics, the STEM area. They will not be able to do it offhand. You have to really write down the expressions and check. So when you look at this particular thing, we decided that our next phase should be to scientific exploration from the moon. At the time it was called the moon mission. It is way back in 2000 when we were saying that yes, what kind of objective should be there. We collected all the scientists and they only defined what kind of payloads are required to be used. So when you are touching the moon, so let me come from the touching and go in the reverse time order. Touching means what? You have to land, the lander should go and touch the moon. But the problem is, when you want to touch, you certainly should reach that point where you want to touch. And you have some requirements on where that point should be. That means you must be able to navigate. Because if you go and touch the wrong point, it's wrong. You must touch the required point. And when you touch it, if you touch it with a lot of speed, then you may touch it, but then that impact will break it. You know that very well. Suppose you take a glass tumbler and throw it from first floor, it breaks, Same way, because it is moved under gravity, it picks up the velocity, and when that hits the ground, that will be converted to breaking the piece. So that should not happen. That means its velocity should be nearly zero. On the other hand, its velocity, how do you make it zero? Because it's being pulled by the moon, and therefore it will automatically increase its speed as it descends. Exactly like a falling apple on Earth. Similar. Only thing is the gravity value is 1/6 of what is there in the surface of the Earth. But then the problem is you can avoid it by keeping a velocity in the opposite direction, so that it's upward velocity, which slowly decreases and becomes zero. That's all possible. But all these are requiring planning, and we are doing all this without any intervention from the ground. It's not commanded from ISRO, not commanded from Bangalore. Bangalore watches it, but many of these decisions have to be done autonomously. Okay, that's very important. But then, in order to get there, where is your starting point? Starting point, it was in an orbit, and it had got something like 1,600 meters per second. That is its velocity along the horizontal. That is, it's trying to move parallel to the moon surface. Again, in the horizontal direction, there are two directions. Vertical is Z, means X and Y are there. So it may be going towards X or Y. That you should now decide based on where do you want to finally touch down, because that is already pre-decided, our target. So how do you do it? You do the deboost, you reduce the velocity, you reduce the height, and how the things have to be sequenced. All these things happen in a matter of something like 10 minutes, no? So that is something remarkable, and that is done by a tremendous number of simulations and people who have looked at all kinds of failure modes and how that has to be addressed. All those were done as part of this planning. But in order to achieve this, what we do is, that's why I said I'll go backward. See, we knew already where you have to land. You want to land near South Pole. And when do you want to land? You want to land when it is locally the morning. Because it's on the moon, the daytime is around 14 days, roughly. And therefore, if you start from the morning, means when it is now, next something like 12 to 13 days, it will have sunlit. And that is important, because otherwise you have to carry a very different power system, which we didn't have. So half a lunar day is what we were thinking. And therefore, you should start when sun is very close to the horizon, but already sunlight is falling. So it's morning time in the local condition. And the terrain where you land should be safe, because there are a lot of boulders and all. So it should be very flat. And because you have to maneuver also. Once you touch it down, you have to drive, So for going from one place to another, it should not go and hit something. So therefore, all those things have to be taken into account. So therefore, you work out based on this, go to the Moon Almanac, and then find out when you have the window of opportunity. And if you want to get into the moon's orbit, from the time you get the lunar capture, there is a satellite which is going around the Earth, has to next go around the moon. So with respect to the moon, it is in a trajectory. So that trajectory must be made into a ellipse. That means, you have to have a maneuver done there. And that is so precise and so challenging for people who fly dynamics. In fact, at the time when this was happening, every day I was sending out FAQs, about 40 to 50 of them. One of them touches on how you capture it. If you had not done the maneuver, it would have gone off from the moon in a hyperbola. And how do you capture it back and make it rotate? Yeah. And basically, we go a little fast, because except that these are all the dates which were 1 year earlier, 2023. And these dates are very important, very critical. We were last year around this time. We were just hardly another 10, 12 days. So therefore, we were very tensed up whether everything is perfect and going smoothly. All the geometry is here. And anyway, there have been some specific presentations to this audience for Chandrayaan 3 mission. I wanted to also mention, when we talk about AI, today, when I read my newspaper, every other day there's one full pager on how important is the AI and what is done in this, that and all. But we have already implemented this Pragyan. When it moved only 100 meters from where it landed to the final site, when it Shiva Shakti point to that point, totally 100 meters. And that was all done using its machine vision, machine learning. And then, because the thing is known in advance, so you have to navigate, you have to go backwards sometimes. And then all those things you did. So the achieving 100 meters in 10 days was a great achievement. And it was done with a team. I've gone and seen that. There are something like 30 to 40 people sitting there and specializing in 7 or 8 different disciplines, all of them consulting with each other, and everything was going very, very smoothly. So that kind of a thing which we are doing. So last part of my talk is going to be, what is the future? What is the outlook? Okay. And there I wanted to mention, there are so many other missions keep coming in. Aditya, for example, was very much in the news when the predicted orbit of 178 or something was finally achieved correctly, and it is in the correct location and with the correct kind of orbit. This orbit is very different from orbits around the Earth or around the Moon and all that. So therefore, the dynamics again was different, and we did that. And it already had produced excellent information. Why did you want to have Aditya in the L1 point? From there, you get a vantage point to look at the sun. You get the information about the sun transmitted to us in advance, so we can take some precautionary actions. Communication link blockage or heavy sunspot activities. All those things have been very successfully done. Of course, we are very, very much into the Gaganyaan. Everybody is talking about it now. The Indian astronauts first going to the ISS and so on and so forth. All those activities are happening. But now, looking at the bigger picture, very, very important, that a space segment has the payload, satellites, launchers, and so on. And then you also have the application area. So you're upstream, downstream, and there are some auxiliary services, like, you are to do the insurance for a particular mission. All those are also developing. And this entire thing, therefore, is now in such a wonderful state. Exactly like how we got the .com time in 90s, when everybody who goes there will have some idea and then he'll start a company, make a very good business. Same way, space is providing such opportunities for young students. When you are all almost you've got such good information which has been gathered. So when you pass out, you will be in a position to join this race as different capacities. And if you look at that, the numbers are, don't worry about the numbers, they are projections. They are talking about by 2030, how much in agriculture itself there will be about $10 billion and things like that. It's a huge opportunity. And then in terms of space enterprise in India, so you have these various entities. One of the very, very important entity is InSpace. InSpace is a single window thing for promoting as well as for authorizing. And that has already created a tech center where you can go and get things done and so on. A lot of partners are there, hand holding is taking place. And that type of stuff has begun correctly. And there are startups, something like 150 startups are there, and many of them have raised money because foreign direct investment is allowed. And space technology brings in not just the industry, the academic institutions as well, because you need the right people trained in these areas and so on. And all of them are brought together for national development. It's something very important and which we have been doing in the very correct way. And the collaboration is among not just the ISRO and one other entity, but any number of others, like Indian Air Force is there here. And you have got things like CSIR, academic institutions, all of them, and the public sector, all of them are in a collaborative environment. And that is all monitored by the agencies which I mentioned. I'm almost ready to come to this thing that one of the opportunities which is going to happen in your lifetime, may not be in ours, I do not know, is in terms of space tourism. Because one have this capability to go out of the Earth, you can do it even for short holidays and trips like that to the moon or to the Indian Bharatiya space station and so on. And if you are doing that, you should be getting ready. Keep that as maybe 20 years from now, I will take my vacation on the moon. And that kind of thing is going to happen. And with those nice thoughts and forward thinking. I want to thank you all for a patient hearing. Okay.
Thank you, Shajil Marsh. Thank you very much. Actually, I don't know how to thank Dr. Rangarajan, my dear good friend, for agreeing to talk to us today in 2 days' notice. Something I was so much reluctant to do, but I was compelled to do because the speaker supposed to come had got into some difficulty, not her own, but because of certain external factor. So I got into this. But my crisis is solved by Dr. Rangarajan. And see, I am very many times, multiple times happy because this talk is so exciting. And it started with a storytelling mode, and it ended up with what kind of things, the impact of space on lives, including the startups today are doing very well. The space station, which the future, he's talked about a story of the past and the realities of today and what we can dream in coming days. It's a fantastic thing, Dr. Rangarajan. I know I want to talk more, but then, there are many students who are waiting there to seek clarifications and information from you, sir. So, and also very many of our colleagues and friends who are your friends, my friends as well, present in this gathering. And I thank all of them for making this event an exceptionally good one and an event which I will never forget. Thank you very much, Dr. Rangarajan, and my dear students and friends who are listening. Thank you very much.
Thank you. Thank you, Gutti, particularly for taking time off from your scheduled other activity where you had gone for your Shira Dhora and all that. So it's nice that you could come and spend some time on this session, particularly. Thank you.
The credit for that is with my doctor who rescheduled my program so as to enable me to.
Yeah. Aisha. Okay. Okay. Yeah.
Good afternoon, all of you. I think what to talk about Rangarajan is a very great speaker and he's a good teacher. No? The way he tells the story, all of us get involved totally from the beginning because some of us are associated with the program from the early 70s. We know what all the milestones we have crossed. Telling the children of today, the 20th, 21st century children, what happened in those days when we didn't have radio, we didn't have TV, and how the space made a difference. It's a storyline we have built over time. Today we talk about 4G, 5G, we talk about moon mission, Mars mission, Gaganyaan, everything we talk about. Those days when we started, I still remember only one small story we'll add here. I was a very good fan of Ajit Vadekar, the great batsman, okay? He used to score so frequently, we are all happy about it. He went on a tour to England and scored centuries there. Immediately, the whole country was elated by that. They erected a statue for him in Indore. Next match, India lost the match there. In Indore, all the people joined together, broke the statue. A country which is so much worried about losing in a cricket match, when a satellite launch vehicle fails in Tumba, there used to be a lot of problem in those areas. They call them sea level vehicle, always sea level vehicle, perennially sea level vehicle, etc., etc. That sort of stage we have started. A lot of failures. Those failures paved way for all the success of today. And as we sit today, Aryabhatta is completing 50 years on April 19, 2025, the golden jubilee year of Aryabhatta. At that time, when Rangarajan talks about touching lives and touching the moon, I think it clears the imagination of everybody, including the students and so forth. I'm very sure that students would have enjoyed this good talk and also be ready to ask many more questions from Dr. Rangarajan. Thank you, Ranga. Thank you very much.
Thank you. Thank you.
He's not here.
Hello, sir. Good afternoon. It's very nice to interact with Rangarajan, sir, because I can say that he is my guru the day I joined in ISRO. So it was really very informative talk, not only for the students, it is for all of us. Sir, only one question I have, because I don't want to stand in between the students and you, because I know the interest of students and the kind of questions they are asking. That is wherever I am, I normally don't miss these kind of things. Though it is too early for me, okay, no problem. I'm still not yet fully ready. I just brushed only. I'm yet to have my coffee also. Sir, one thing which I wanted to ask you is how the dynamics of operations of this low Earth spacecrafts is going to make with respect to geostationary spacecrafts which are currently in orbit or planning to be launched in the orbit. Because now what they say is already Elon Musk is planning to have thousands of spacecraft, as well as now China is also in the race. They have also started getting into the constellation. I just wanted to have this because let us hear from the lion's mouth how the dynamics going to be changed.
Well,
thank you very
of
much,
course,
sir.
Yeah. I mean, this is where I was talking about the golden circle, no? Going radially outward and radially inward. We always went from bottoms up, and we knew that we wanted a geostationary satellite so that we'll get the meteorological observations. We want to do the broadcasting and all that. We did it like that. But now, take Elon Musk or any of those other people similar. There is very highly supply driven because they have got a supply chain which can produce these satellites just like that. They have a launch vehicle capability which can launch tens of satellites in one shot and very little failures. So they can easily populate the whole thing with whatever objects are there. And within that, what payload you want to put is where they have their business plan. And their main idea is somehow try to get into this because the satellites give you the uniformity or ubiquity. So therefore the villages, like we have 600,000 villages in India. If somehow we can get to talking to our people, convince them, or I won't want to use the word brainwash them, saying that without this connectivity, all those villages will go to dogs. All their friends will be doing very nice social networking, Instagram. This poor child will not be able to do Instagram, or she will not do any other thing. Why don't you please provide them very, very good connectivity, large bandwidth, which we know how they will use. We all, because I live in a village, I know exactly if you provide large. Instead of that, if you had given very specifically even one-way broadcast content to them, it will be more productive. But then that is the marketing. So they market it so well. And then once they come in that manner, and if they start saying, "We see our terminals are so small, they are personal, and if they can provide this bandwidth, everybody will fall for it." And if numbers go large, they can make it very much cheaper. Presently, it is not. So once it comes, that may be the end of the story for things like geostationary, etc. Besides, of course, the interference and other problems also would come. But then the bandwidth and the kind of signal strength, etc., which you provide from a geostationary platform can never match with what you can get from the LEO constellation. So every one of those functionalities they mentioned, whether it is education, health, or agriculture, everything will be taken care of by this constellation, whether it's Chinese, for example, or Starlink and so on. It may be good or bad, because for me, I believe you should always come from requirements and design the system, implement the system. Okay.
Thank you, sir. Yeah, I'm
All right.
leaving to the students. Thanks for the
I know.
enlightenment.
Thanks
This is what
again
we were
for getting
also
up very
fearing.
early.
Yeah,
Okay.
this what we were also fearing. Probably, yes, finally all the efforts are going to be taken over by them. Of course, we'll have to be only onlookers. Nothing we can do. Thank you, sir.
All right.
Can I get?
Yeah, Joshi is back. Yeah.
Okay. So I will not take much time, only 1 minute. I had an opportunity to listen to Dr. Rangarajan when I visited MCF Hassan. And it was 1978-79 era. I set 2 series of satellites. And in one of the debriefing meeting, one particular point was getting discussed. And systematically, very nicely, he briefed the entire committee. There was not a single question. And from that moment onward, I am a big fan of Dr. Rangarajan. Whenever I see an opportunity, I always find it that I should. And currently, I am not in India, but I made it a point that whatever be the time, I would definitely attend this lecture. A huge compliment to you, sir, and my pranam. You have been a role model for so many of youngsters like us on those days. Thank you, sir. Thank you very much for your elaborative and very lucid talk today. Thank you, sir.
Thank you. Oh, okay.
Yeah, so thank you. First of all, thank you, Kuti sir, for inviting me for this session. And thank you, sir, Rangarajan sir, for this wonderful session. So it was a very informative session. And it is always good to know how things have started and then reached at a level, rather than knowing only the top level of the things. So especially as Shajil Mash was telling, we are just about to set up a satellite research center with the help of Anand Technologies and the UL Space Club, and with support of all these Kuti sir, Shajil Mash, and all other our well-wishers. So thank you, sir, for this session, wonderful session.
Certainly, Raghu. Thank you, and we'll meet. Because last time itself, when you were coming to Anand Technologies, I wanted to have meet with you. We'll do it on your next Bangalore visit. We'll make sure that we connect and make, and your program is so well.
We would like to
something very close to me, because my co-brother was with NIT for almost 30 years.
Okay.
Roy Venkatramani.
In electronics.
Electronics.
I'm also in electronics, so I have heard about you.
Yeah. So Dr. Ivy is my co-brother.
Okay. Yeah, we want to make our center make a good progress in our center. So we'll request your help for that.
Surely.
Fine. Okay, sir. Thank you.
Just one moment, Shajil Mash. See this right now. Our Varun, the student leader of the Space Club, is with Anand Technologies. He is working with some of the people on a satellite communication satellite project, and doing very well. So I just wanted to make this occasion that our students are encouraged by Anand Technologies in a great way. Thank you. Thank you. Shajil Mash, let us go to students now.
Yeah.
Yes, sir. Very good evening, sir. And today's session was incredibly insightful, and we truly appreciate your time. And some of our curious minds have a few questions they would like to ask. So, starting with, we have Adil Prajesh, who asked, I think this is what he meant. Is ISRO planning a manned mission to the moon in the near future? And if so, what would be the primary objectives and goals of such a mission for India?
Yeah, I mean, it's a very, very good question, because once of course, we are beginning with our Gaganyaan, where we first get our sense of getting out from the Earth into near Earth, staying there, coming back. But then very soon, the transportation to moon is going to become a routine affair. It can go directly from the Earth, or maybe with one stepping point at the Bharatiya space station also we can go there, and from there you launch to the moon. And the reason why we want to go there could be several. First, initial 1 or 2% for the excitement you go, but that is not our reason. We want to explore the moon. Moon has got very interesting minerals and capabilities, and all those must be exploited. And we are also part of other international missions like Artemis and all that. So now, when the Indian, ultimately, the space law also is evolving to decide on who should go and be able to construct something, live there, or maybe build a telescope and view the sky from moon. And if only, for example, water is found, from there you can get hydrogen and you can get oxygen, and that hydrogen can be used for a cryogenic propellant, in which case you can go very much more efficiently. You can send rockets from the moon. So these are all forward thinking, typically 3 to 4 decades from maybe, around that. So therefore, initial reason why people will go is to find out what other opportunities exist there and what other materials, etc., would be of interest to be brought from moon to the Earth. India will definitely be there. And as the Prime Minister also has set clear deadlines, like around 2050, we should have this kind of a colonies there.
Thank you, sir. And he also asked some other questions. And ISRO has pursued unique missions like Aditya L1, focusing on the L1 point, and Chandrayaan, targeting the lunar south pole. What is the strategic significance of selecting this specific location for exploration, and how does ISRO determine these targets? Can we expect some similar groundbreaking missions in the future?
Yeah, always that will be there. As I was mentioning throughout my talk, we do what's called bottoms up, which means we get the reasons. Like South Pole, we decided to go is not because we had the capability to go to the South Pole. It is because the scientists in the country want something to be explored in that region, because the terrain is very different. I don't want to use the word terrain, might look like Earth, or equivalent of that in the moon surface around that the lunar South Pole has some very interesting things because of the way it has got weathered. The sunlight is coming less. It cycles through thermal cycles which are very large and all. So therefore, there's a lot of scientific interest in such regions. Same way, L1 point, from there to observe what kind of things which can be seen about the sun and sun-related studies is governed by people in the PRL. The payloads are all made by Indian Astrophysics and such institutions. It is they who decide what should be the mission, which means what is the payload, what is the orbit, where it should be parked. So this will continue in the future. So very exciting new missions are certainly going to come out. And even good old days, I showed AstroSat. I know the person who was the chief designer for that is a very good friend of mine from TIFR. And I had met with him about 5-6 months back. And he was explaining how ISRO and TIFR worked together and made sure that we have one-of-a-kind mission, which even today is producing research papers and PhDs. So therefore, it is decided by the scientific people in terms of science payloads, communication usage people for communication payloads, remote sensing users for remote sensing payload, and correspondingly, satellites are getting made. We always respond to their demand, not the other way. We don't first make something and say, come on, you go and use it.
Okay, sir. Now, DRC from 11th grade asked, how important is data science in the field of rocket science and space exploration at ISRO? And is a strong understanding of data science essential for those involved in designing and launching rockets?
Yeah, basically what's happening, the entire activity in the space sector is highly multidisciplinary. Even many other fields, they're all becoming more and more multidisciplinary. The compartment that very distinct compartmentalized learning, it will never work. For example, AI or machine learning and all that comes up in almost in medicine, it comes up, biology comes up, and it comes in obviously space sciences also. So therefore, data science, when you say in the 11th grade level, yes, it may be called data science. As you go further on, it'll bring in not typically coding or programming, go beyond that in terms of utilizing the data, interpreting the data. Such kind of things are very useful wherever you are going to work, and certainly in space. Because as you say, STEM, no? There's science, technology, engineering, mathematics. Those form the pillars. But these are all, at that time, very broadly defined. But right now, more details when you go, data science is very, very useful. And if you have the passion, then you should continue to do that. Because that is very important. Your passionate curiosity is what leads to success. And that is very important. You should create that passion, love those numbers, like data science people. The moment you see these numbers, oh, this looks like a curve like this, and so on. And that kind of a feel is what is very important. Don't just be interested in getting full marks for the answer. The answer can be found, and answers have been already there in the backside of the book. But the methodology is what you should learn.
Okay, sir. Amrita asked, how does ISRO or any space agency plan to track a satellite or spacecraft if it were to leave the Milky Way galaxy? And what are the challenges involved in tracking objects at such vast distances?
It's very, very, very challenging. One is because of the distance, and because of the distance, there is a time delays which are involved, which means you cannot take any quick action back and forth. And even for Moon, I was telling you that when we are doing the final landing and all, we allowed it to be done by its own intelligence rather than feeding it from the ground. Okay, so when you go farther and farther, it becomes extremely difficult. But nevertheless, there's always a silver line there. I don't know how many of you have been following. One, I don't remember what the name, about 40-year-old mission, about 2-3 months back. NASA was able to go back and take the data out there. They found that something has gone there. So they were able to replace the code by sending commands. Such a difficult task, but they did it, and it started giving the data correctly. That kind of, yeah, exactly. So that gives you that you never give up. That's a very important attitude. All of us, many of my colleagues are here. We all have grown up with that. And that is one thing which you should always pick up. And so these missions at first sight may look very difficult. But the moment you start working on it, you'll get some bottlenecks, but you will be finding ways of getting over it and move forward. And the mission should be planned in full condition. And there are people who have done it. India has not done that much of going to asteroids around, far. If you are talking beyond Milky Way and all that, it's a question of distance involved. So you have to only observe rather than sending a satellite and all that, because those distances are too huge. And within one's lifetime, you are not going to get back the data for analysis.
Okay, sir. Thank you. And now Adidev from 8th grade asked, is ISRO planning on making a heavy or super heavy class rocket similar to Falcon Heavy or SLS in the future?
One thing I'm amazed is an 8th grader is able to even go and sort of look up in the web or wherever, and then getting Falcon Heavy and all that. Very nice. So
and
that
he even
asked
continued. How is the development of ISRO's semi-cryogenic engine going on?
See, that is fantastic, because at 8th standard, we never would have ever thought of even solving an equation would be something so difficult for us. But now that's nice, but make those kind of good opportunities. And these are things, when you are talking about heavier and heavier rocket, we again in India, time and again I'm repeating, we do it based on our requirements. We want for Chandrayaan 3, we wanted this kind of rocket, we have done it. So if we want the next one, we don't just allow we have got centers where launch vehicle is doing. We don't just tell them, go ahead. You have done so far 8 tons. To next year, your job is to make 22 tons. That's not the way it's all given. Unless it comes from their requirements that you have to develop and upgrade, we won't do it. And from that point of view, you therefore should not take that as the end goal. It is a means to an end. That's very important. You should achieve your requirement by building those cells. Then we have the capability to do that because we have got plenty of research done. And we know all about these engines and how they have to be integrated because it's a question of controls. How, when you have very heavy lift off, after that, controlling the dynamics, the guidance, those things are very tricky. And we have got excellent centers, sub-centers, which all have developed the know-how. We'll put them all together.
Devananda, just 1 minute, half a minute, Devananda. This boy, Adidev, is his mother brought him to me in the 5th standard, saying that this boy is so much obsessed with space. So can you do something? And this boy in 6th standard, he came to AN Technologies with a group of other students who are all in much, plus 2 and graduation level, and a teacher like our Shajil Marsh, etc. We went to Anand Technologies. He was a team man in that 8 people group. And after our visits are over, I asked each student to make a report. This report was adjudged as the best report of what he saw as a satellite center there. Just for information.
Very good. You see, in the group now, I should see his video, if possible. His mom or somebody could help to, so that we look at this boy.
Adidev.
Can you put up
I think sir mentioned about Adil Prajesh, I guess.
No. This question was Adidev, isn't it?
Yeah, Adidev, can you please turn on your video?
Yeah, so that we can see.
Adidev, are you there? Mone, are you there? Adil Prajesh is there. I know. I saw his question. He's also like him.
No doubt.
6th standard. Adil Prajesh has come to us at 6th standard, and he is now in 8th.
Okay. Very good. Keep up the same spirit. You have got excellent opportunities through your club. Proceed, Shweta.
Okay, sir. Now, Vasudev from 11th grade asked, this is such an interesting question. How were we able to capture images of the Milky Way galaxy if we are inside it? And wouldn't we need to go outside the galaxy to take such pictures? And how is this possible? And does scientists know how the Milky Way galaxy looks like or what?
See, what happens is in order to look at any object, if you want to see it in a full, you want to go outside, then you get a full image of that is what you're looking at. But on the other hand, we have image processing techniques by which whatever portions of that object you start capturing, and then you can all stitch them together. You can now make a mosaic, you can get what will be there. So therefore, Milky Way, first of all, is not an object like that. It is a full collection of all these stars. So therefore, it's something which can be modeled, and whatever portions which have been imaged, from there you will follow, and then with the dynamics, everything put in, you will be able to visualize. So it's not like for visualizing, you have to go outside and take a picture. You visualize based on the model.
Okay, sir.
Yeah.
Ashwin Sridev asked, after the successful PSLV launch, what does ISRO have planned for the future of low-cost under-medium lift category of maybe hypergonic rockets?
Okay. Of course, I wouldn't know offhand the details which he has got. But of course, one of the important things which you should watch out is on this Independence Day on the 15th, we have the SSLV launch, the third launch of that is something which is going to be so interesting because it's meant for on-demand kind of launch for small satellites. Therefore, that kind of a launch vehicle is a totally different class compared to the PSLV or the LV Mark III.
And now this is kind of a general question. Hiba Fatima from grade 8 asked, what subject should we take in 11th grade if we want to take job in ISRO?
First of all, two things. let me answer the second part. You don't have to be taking a job in ISRO, because ISRO is actually downsizing and giving away all these kinds of hand-holding to everybody else. There will be a lot of companies, a lot of entities to which you can work and contribute to the space sector. Okay. And what subjects, again, it's very important to understand that it is not specifically one subject or the other where you specialize in order to get to that. The more you are broad spectrum, you try to look at more than one, an interconnection. See, for example, I always have believed I've studied physics, but mathematics is something which I liked. So therefore, whenever I learn something in physics, I would like to look at what is there in mathematics and vice versa. You see, quite on a lighter vein, all of us spend a lot of time on the Olympics. For me, as a physics person, what is very interesting for me is that yesterday I was watching the javelin throw, the final things where, of course, India got the silver. And each time, before showing the distance the javelin traveled, the TV was also displaying what is the angle to the horizontal that the thrower used and what is the speed with which he released. We in our high school have studied, how a projectile would go on a parabolic trajectory and how would it go and what kind of a range it will achieve and so on. And the range, how far you go, depends, as a physics man, on two aspects. How long the object stays above the ground, because if it hits the thing is ended. So therefore, to keep it longer, you should have a large vertical component because it has to come zero and come back. And on what speed you go, the horizontal component is propelling forward. And therefore, that if you have a large speed, it will go longer distance. But physics tells you that the two of them combine at 45 degrees when you launch. You get the combination, you get the maximum range. But interestingly, I have noted down, see, at my age, I took a notebook and I can read it out for you. I have got my notebook for almost about 50, 60 readings. Most of them take 30, 31 degree, 34 degree and things like that. I am trying to correlate how that and the range achieved, how does it matter? Of course, javelins, its dynamics also have to take into account. It's a very long rod and therefore how in the air, aerodynamics and all. But that apart, it's very exciting to know that. So like that, if you look at it multidisciplinary, you'll be able to do things very differently. Look at something here, immediately that should say, oh, there's a differential equation. Next time you do, this chemical equation, I know that this particular thing is so much is the mole fraction. Like that, you bring in biology. All the different things you should interconnect. And that helps much more than specializing. Getting the depth will come automatic. Depth will come when you go on the job, you'll learn. But don't have to do too much on that. I think Vijay has got a comment on that.
Just add one more thing. You can do biology, you can do chemistry, you can do physics, any subject for example. In fact, under me, a lot of people working on agriculture, water resources, environment, climate related, meteorology related, they're all part of ISRO today. And you would have learned about recently the flood mapping, what we did for the Idiki area, Wayanad area. A lot of scientists are involved in interdisciplinary only. So any area you take, anywhere you can enter. But nothing like you have to do only electronics, you have to do only physics, etc. You can do whatever field you like. In your own area, you can develop space technology itself. Okay. As Rangarajan put it, the user is oriented. User wanting something, user is not a technology guy. He is a scientist working in his own area. A physicist or a geochemistry guy, sitting in mineral guys, they are going to ask you a requirement. So you have to probably interface with them more than with the technology guy there. If you want a lot of people going to interface, that is also very important for space. Thank you.
Excellent.
Okay, sir. Now, Adil Prajesh asked a simple but elaborate question. What is the future of ISRO? And given ISRO's remarkable achievements in recent years, including missions to the moon, Mars, Aditya L1, and what is the long-term vision for ISRO's future? Like, how does ISRO plan to evolve in the next few decades in terms of exploration, technology development, international collaboration, and contributing to global space research?
Yeah. There were always, earlier ISRO was a single umbrella. We were doing all this, whatever you mentioned, plus building our own systems, manufacture, all those things. So now what is going to happen is with the restructuring of the space industry, with a private participation. Okay, so they are also coming in to take over certain things where it's clearly defined, infrastructure exists, assets exist, and they run the business out of that. So that component will be taken out, leaving ISRO with more and more to concentrate on the R&D, more of a development. See, for example, the interplanetary and all that are coming only under the requirements for a much longer term, and therefore no company will be interested in directly contributing and holding a mission like that. So ISRO will continue to do all those, and international cooperation. That's again, like just now also we mentioned how the lunar program has now suddenly become very much international, and we will work with our like-minded other countries to work together so that we don't reinvent the wheel. Even when you go to the space station, for example, already we were not part of that. But now that our astronauts go there, maybe we will know, yes, these are all the things that happened, and take the jump start. And in our Gaganyaan mission, we will have to get to doing something which has not been done in the space station and things like that. So therefore, to that extent, this whole scenario is very dynamic, very fluid, and it's going to be very exciting. And it all depends on who is going to drive it and how the private industry is going to support it. Previously, ISRO was supporting the private industries and all. Now, private industries at some point of time will have all the structure to support these ISRO activities.
Okay, sir. Someone asked, if we have to build a drone for Mars, can we make hybrid propulsion system for a drone for Mars, as the atmosphere is less denser there than Earth's atmosphere? If it can be done, can you give some ideas?
Yeah, incidentally, the one who did the drone for the US mission, is a person from our region, one of the Indian origin persons, that lady only has done that. And it required a tremendous, it's very different, as you correctly said. Once you have less gravity, and it has a lot of carbon dioxide, and it has got so many other issues. So with all that, they were able to do so many times restart and, the helicopter kind of thing. You're talking about a drone in general, and for flying a drone there, you have to take into account the atmospheric conditions, which are all very well documented. So designing that and testing it has to be done. And the simulation, all those things have to be done before you can really launch something like that. Because it's not amenable for a repair, Once it goes to Mars, it has to function error-free. And that and all you have to prove. So it takes a couple of years of work there.
Okay, sir. Hiba Fatima from 8th grade asked, what challenges did the Chandrayaan-3 team face during planning and execution of the mission?
Yeah, plenty of them. Because Chandrayaan-2 was almost a success. September 6th, the date, I still remember how at the hours of the morning we were expecting it to land, but it crash landed. So therefore, by then, we knew what were all the things which we may need additionally. And firstly, because the Chandrayaan-2 was doing the imaging of moon, so we were getting lot more information than Chandrayaan-2 itself had when it was trying to land. See, that's the beauty of Chandrayaan-2. It was providing the vital data for Chandrayaan-3 to succeed. So therefore, with that terrain information, then planning the trajectory, choosing the spot, and then how to navigate to that point, all those things had to be simulated. So you have, and there were some other things, the thrusters and all that were made, in a better, whatever lessons we learned, we corrected them. We did a lot more of simulations and checking. And with all that and the initial starting point, everything was done in such a manner that the Chandrayaan-3 would not have any, very, very, very little chance of anything failing. So it has to work. And that comes with that, always, even Vijay also talked about how we had initial satellite launch vehicles were called sea-loving vehicles and all. But we didn't give up. From there, we knew why it did not work, why the second stage did not start. All those, when you answer that, you will be able to find solution. That's a very important thing. See, it's not like you cannot fall sick. Once you have fallen sick, you should know, the doctor should be able to decide, this is what is failing, and then you strengthen, you give them the right type of medication, and then the next time, same environment, you will not be falling sick. That approach has to always happen. The feedback is important.
Okay, sir. So I would like to ask a question. I am an architecture student and also got a passion for space. So what opportunities and roles exist for architects within the space sector, and how can architectural expertise contribute to space exploration, habitat design, or other aspects of the space industry?
In fact, in your question, you made a very, very good thing, habitat. See, the lunar habitat design is going to be a very interesting kind of project because, first of all, it's assumed that maybe it will be slightly under the surface, okay? You have a lot more of this thing, and then robotic missions are planned in the next 1 year, 2 years, it'll start. So now when you want to design it, you have to design so that you have enough space for your normal movements. You should have enough strength. Because, everything is unknown. That you must remember. The temperature gradients are different. This material is different. So whatever you have learned in your classroom will not work. But whatever methodologies you have learned can be applied. So when you do that, you'll be in a position to come back with the right structures. Suppose you want to make a vegetable forms. How do you develop that? It should have what kind of a temperature should be there. What kind of a see, air and all that is not there. The oxygen will not be there on that. How do you substitute for that? Some tubes and all will come. All those will be designed only by the architect. And ultimately, if it is going towards the space tourism, you have to make it even better because the tourists will look for certain very basic amenities. Those all should be provided because they are not the normal explorers. So they will not take it for this will not work. And also you have to provide the right type of hotels, hospitals, all those have to be constructed. Because
Sweta, you got the answer, Sweta? Sweta, you got the answer?
Yes, sir. Yes, sir. I'm planning on.
You are under fear that once you get into architecture, you may lose your dream of space, isn't it?
No.
So,
I'm also kind of interested in sustainable architecture and all, biomimicry and stuff. So
very good. Very good. Now, space has a lot of scope. Because especially it's multidisciplinary, when you come in with your region or your expertise in your field, and that will help in a team. You would be immediately able to get answers when the discussions take place. You'll say that this is the way it has to be designed. You provide this. Because I'm not a great architect, so I wouldn't even know. Not just the look of it, but the civil engineering part, everything, how you take the waste disposal, how this should be piped in, everything must be properly put together, no? So that's all architects work on.
Local materials also.
Yeah.
Thank you, sir. Now there's a question by Adil Muhammad. He asked, what is meant by Oort cloud? If I'm getting the pronunciation correct. Oort cloud. O-O-R-T cloud.
O-O-R-T. I'm at least I do not know.
Okay.
Anybody else? O-O-R-T.
Let me pronounce it wrongly.
Yeah.
I think it's named after a Dutch scientist.
Yeah, but which context does it come? Does he know? Where did he read that?
So can I please comment?
Please.
So the Oort cloud is basically a cloud that marks the end of the solar system. The sun's gravitational force is still the Oort cloud. It consists of a lot of asteroids.
Okay.
So it's a huge sector.
Yeah, it's called Oort cloud.
It's called Oort cloud, yes.
Yeah. It's a cloud of asteroids. That's what you're saying. A lot of asteroids at the end of this thing there. Okay.
Yeah.
And what was your question on that? How do you?
Can Adil Muhammad please explain how you got into this topic and
what is your doubt on that, Adil?
He just asked what is meant by that. I think he read it somewhere.
That is just that. When the solar system was formed, as correctly told, all these were sort of collected there and they form a huge collection. So that's why they call it cloud. At the end of the whole system.
Adidev asked, are there any Lagrange points in the Earth-Moon systems? If yes, are there any spacecraft there?
Oh, very interesting. See, whenever you take two bodies, okay, there will be Lagrange points will come up. Okay, for two bodies, you have just two bodies, whether it is Earth, Moon, or you take Earth, Sun, or Sun and Jupiter. You take only two and remove everything else. There will be 5 Lagrange points. Okay, they are called L1, L2, L3, L4, L5. And L1, L2, and L3 happen to be on the line joining the centers of the two bodies. Like here, suppose you take Moon and Earth. You assume Earth to Moon, that the line is joined. L1 would come in between Earth and Moon. L2 will be on the same line on the other side of Moon. That is L2, Moon, Earth, like that. And L3 will come on the far side. That is Moon, Earth, L3. So all of them are on the same line. L4 and L5 happen to be in such a way that it's an equilateral triangle type of thing with the Earth to Moon as the base. And 60 degrees, if you construct it, will cut the orbit somewhere, no? That is where the L4 and L5 is below that. So these are the 5 Lagrange points. Yes, they exist certainly for Earth, Moon.
Okay, sir. Now, Adil Prajesh asked a simple question. Planet 9, question mark.
What time?
Planet 9, question mark.
Or whether there is a planet 9. Yeah, I mean, these are all sort of speculations and beyond. And, unless you are working in that field, you would not know exactly when and what will be discovered and not, and so on. I will leave it only at that. So let it continue as speculation with a question mark.
Okay, sir. I think that's it for the questions.
Good. Very
Shajil
good.
Sir, I would like to hand it over to you. Thank you so much, sir.
Yes, sir. Am I audible?
Yes.
Sure, sir. Okay. My name is Devananda Srijit. I'm studying in 9th standard and I'm from Calicut University. So I'll be here presenting the vote of thanks for today. So I'd like to say that on behalf of the UL Space Club, I extend my deepest appreciation to Dr. Rangarajan sir for sharing his wisdom and time with us. And so your guidance and mentorship helps aspiring space scientists and engineers like us a lot. And to be honest, we are truly fortunate to have had the opportunity to host with such a distinguished personality today. And not only that, this webinar has not only broadened our knowledge, but has also reinforced our commitment to contributing to India's space program. Thank you for taking time and efforts for us. Thank you, sir. And I would also like to express my gratitude to the Space Club for organizing this incredible event and creating platforms for knowledge sharing. And most importantly, thank you everyone for your active participation and insightful questions. So let's carry the inspiration from this webinar forward, and together, let's continue to reach for the stars. Thank you, sir. It means a lot to us. We hope to have you again.
Sure. Now, next time in person, I'll come there to Calicut, definitely. Okay.
Thank you. Thank you very much. It has been an exciting afternoon for us. And you have taken us to great heights. Beautiful. The whole environment and the ambience of this webinar has been excitingly well done. Thank you very much.
Thank you. Okay. Well, sign off.